Yeah. Oh, right, the warm-up. Sorry. Yes, let's go over the warm-up here real quick. All right. For number 1, from the warm-up there, number 1, if you remember from the warm-up, it was x plus 4, that quantity, times the quantity x minus 3. So you said, well, what do we do here to solve this from the warm-up? Yep, exactly. Right, 0 product property. If 2 things multiply to give you 0, that means 2 or more things. That means one of those 2 things has to be 0. 0 is the only number that has that property, so that's why whenever you want to factor and solve, you need to make sure it's equal to 0 first. And so negative 4 and 3 are your solutions there for the first question in the warm-up. And then for number 2, similar kind of idea. Set each one of those factors to 0. So for number 2, you should have gotten x is 0, x is 41 halves, and x is negative 9. Okay. So I guess, yeah, actually that's the warm-up, and this is the end of the week, so maybe if you guys don't mind tearing your warm-ups out too real quick, all right, Seamus can come around and collect those warm-ups for me. All right. There's only 2, yeah, so sorry, I know it's kind of a waste of paper, but okay, we'll figure something out. And Seamus, I'm going to put the grade paper on over here. It's the very last column, Seamus. Okay. All right. Thank you, Heron, for reminding me to go over the warm-up. Not a bad thing to do. All right. Here we go. So again, this is review from previous, classes and things. So I hope we can. I'm going to move through some things quicker than others. When it comes to solving quadratic equations, I guess there is kind of one tried and true method. That's the quadratic formula, right? We'll see that at the very end. But there's a lot of other tools that we have because the quadratic formula is not like the easiest thing to use, and it's very cumbersome. Lots of little calculations you have to do, lots of opportunities for mistakes, right? And you don't always need to use it. So when we have certain kinds of quadratic equations, for example, sometimes when we see a quadratic equation, we want to first start by trying to factor out a GCF. Okay, to solve. So that's going to be one of the first kind of tools we want to utilize here, factoring out a GCF. Okay. So just as an example, okay. Again, all these examples we're doing today, the directions would be something like solve for x or something like that. Okay. So let's say we had 3x squared plus 5x equals 0. Okay. So this is a quadratic equation. Right, but we don't need to factor in any sort of other way other than really just factoring out a GCF here. What would the GCF here be? X, right? So we take that x out, and then what will be left behind? The 3x, right, and plus 5, right? Okay. Now, why does factoring help us here? Well, now we've gone from a sum of 2 things equal to 0 to a product of 2 things that equals 0. And since we have a product of 2 things that equals 0, that means one of those 2 things must be 0, right? When you add 2 things together and they equal 0, one of them does not have to be 0. But when you multiply 2 things that equal 0, that means either that x is 0 or that 3x plus 5 is 0. Well, if x is 0, that's done. You've got a solution there. And then we can finish solving here. We get 3x equals negative 5 or x equals negative 5/3. So that's another solution. And there we solved the equation. We found values for x that would result in our equation being equal to 0. Of course, this is not the only way to solve this, right? Whenever you come across any equation in your entire life, bless you, if you have your graphing calculator, it's easy to solve any equation you ever come across. Graph the left-hand side in y1, graph the right-hand side in y2. Okay? And then where those two left-hand side and the right-hand side, where those 2 things intersect, the x-coordinates are your solutions. Right? So if you were to graph 3x squared plus 5x, and you were to graph the line y equals 0, you find the point of intersection, you would have one that would intersect at 0, and 1 that intersect at the next x equals negative 5/3. Okay, so there we go. All right, let's try another one here. All right, let's do like 2x squared equals 8x. All right. So we want to solve this. We want to solve this thing. So how might we go about doing that? Ideas here. How do we go about solving this? Zach, what do you say? Subtract 8x from both sides. Right? And now you look at that and say, okay, let's see here. There is a GCF we can factor out. We can factor out a 2x. And we'd be left with an x minus 4 equals 0 there. Okay, so again, two things multiply make 0. That means 2x equals 0 and x minus 4 equals 0. So x is 0 and x is 4. Okay, so again, nothing too crazy there. Now, yes, Caroline. Okay, great question. Thank you for asking that. So, and I'm assuming that some of you were maybe thinking that too, but you just didn't say it. So the question was, could we divide both sides by 2x? And the answer is yes, but we'd be left with x here, and 8x divided by 2x is 4. So Caroline, when we do that, we only get x equals 4 here, right? We miss that 0. So here's what we want to be careful with, okay? And the situation, the problem arises because we're dividing both sides with an x, okay? Whenever you divide both sides by x in like an equation situation, right? We don't know what x is equal to what x, what x equals, right? And in this case, in fact, x equals 0. So when we're dividing both sides by 2x, we're kind of dividing by 0 in a way, which is, kind of, not good mathematical ground you step it on. So, long story short, you want to actually get everything equal to 0 and be very wary of ever dividing both sides by x. So while, yes, you do get that 4, we would miss that 0 there. So that's one thing you want to be careful of. Okay. But I'm glad you said it because I was going to hit that anyway. Yeah, Jake?
Stupid question. How did you go from 2x squared minus 8x to 2x
right.
minus 4?
So again, right. So the thing here, right? So first of all, I'm kind of helping you guys out a little bit, right? Because I'm telling you, here we're going to do this problem, but I'm already categorizing it under a GCF kind of thing. So like, I'm kind of throwing this out and saying we're going to be using the GCF, and you guys know to use the GCF. In real life, right, on your own in the wild, you'll be given a problem like this, and you won't be told, you won't be held by the hand and told what strategy to use. You'll just be given this and said, solve it, right? So you need to know what strategies to use. So that's step one. So since this is in the GCF section, we're going to try and use GCF here, a greatest common factor. So if you look, right, 2 and 8, both are divisible by 2. We can factor 2 out. They both have an x as well, so we factor the x out. And so then what's left? Well, an x would be left. If I take a 2 and an x out of here, an x would be left. If I take a 2 out of 8, 4, right, because we're dividing each other, and then dividing out the x. Okay, make sense? Yeah. All right, so there it is. All right. All right, so yeah, that's that. That's factoring out a GCF. So always, always, always try to factor out that GCF first. All right. I also want to stop and make mention here real quick of the difference of squares, okay, which is a special a form of quadratics, right? I'll write it up here. A difference of squares, again, is not very creatively named. It's a difference of perfect squares. That's what it is, okay? So it's a squared minus b squared, which will always factor to be a minus b, a plus b. Okay. Difference of squares. So we can take something like x squared minus 36 equal to 0. Okay. There's no GCF, right? But it is a difference of squares, right? X is a perfect square, 36 is a perfect square, and so if you really want me to like kind of make this maybe a little bit more obvious here. So then the x is like our a, the 6 is like our b in this case, right? And so then we can just kind of follow the factoring here. It's going to be then x minus 6 times x plus 6, and that's still equal to 0 there. And so again, we have a product of two things that multiply make 0, so x minus 6 equals 0, x plus 6 equals 0, and so we get x is 6 and x is negative 6. Now, Caroline, can you think of something different we could do here? It's kind of like what you wanted to do before. Well, in a sense, it's kind of like what you did before. Like back up here, where it was like 1 was already on the other side. So we could add 36 to both sides here. And then at this point, Caroline, what do we do? Yeah, we could square root both sides here. Right? And we get then x equals plus or minus, because we're in an equation setting, that's 6. And so you can also go about it that way too. Okay? So that's fine. We're not dividing both sides by x, thank you. Okay. Yes,
Could you do the maybe square cell also?
Square. Let me think. I don't think you could complete the square with this, because there's no middle term.
Oh,
Yeah. So, yeah, this cannot be rewritten as a perfect square. Yeah. No, yep, you can't do it. Unless we, like, put a middle term in, but then we'd have, like, x's on this side, too, so yeah. Yeah, interesting. Nope, just the different squares there. All right. So, of course, you know, we could do other things, too. Let's try another one here. 8x squared minus 18 equals 0. Okay. So actually, how about you guys try that one there? Go ahead and try that. I know I just said it as an example, but you guys try that. Okay. So 8x squared minus 18 equals 0. See what you can come up with there. And feel free to use any strategy that you would like. Okay. then also forget 2x plus 2x plus 3. So almost 4x times 4x would be 16. Right? Meaning 4x squared is much in your coefficient. So what has one been 4? Exactly. Right. So the 2 is there, and we can multiply together with these things to make 0. The thing is, like the 2, you could set it equal to 0, but 2 is 0. So this is, it's not, I mean, it's there, right? Like this is equal to this, but when you're trying to find the solutions, you only have to those things to the x. Be careful here, you also want to use the square root of 9, so 2x minus 3. Yeah. No, that's okay. So there was a 2. So actually, look, this is 2x, because when you factor 2 out, it was 4, right? You take the 8 over, back out 2 4, so then 2x. And then 2 right goes nowhere. 2 and I'll just explain to you just obsolete one. Well, so basically this. Yeah. So the 2 is still here. Right? 2 2x minus 3. And then you said your factors equal 0. No? Equal 0. Never. So then you have x plus 3 equals 0. And you have x plus 3 plus 0. So you can solve these. So while this is equivalent to this, we're trying to solve and get x by x and make it 0. The 2 will not be helpful. There's no reason to provide it. Does that make more sense? Okay. Again, in the interest of time here, we're going to press on. So there are our solutions, okay? One way to do this, okay, is to use the GCF and difference of squares method, okay, if you factor it, because right now as this is written, not perfect squares, right, not squares, but you can factor 2 out, you get 4x squared minus 9, okay, and that 4x squared minus 9, 4x squared is the perfect square of 2x, so then this factors to be 2x, and then of course 9 is 3 squared, right? So it becomes 2x minus 3, 2x plus 3, which then solves to be 3 halves or negative 3 halves there. Okay? People were asking me, what about that 2 in front, Mr. Wid? Like, that's part of the problem. And you're right, it is, right? 8x squared minus 18 is equivalent to 2 times the quantity 2x minus 3 times the quantity 2x plus 3. But that 2 in front is not helpful for any solutions. There's no x there. So yeah, you could say, all right, the 2 is also equal to 0, but that's never true. But 2x minus 3 could be 0 if x is 3 halves. 2x plus 3 could be 0 when x is negative 3 halves, so that's where those solutions come from. Okay? Alternatively, you could have added the 18 over, divided both sides by 8, and then taken the square root of both sides and gotten the plus or minus 3 halves as well. That's another alternative. Okay? Should we end up with negative, like square roots of negatives, all right? So should we end up with square root of negative? We're going to ignore that, all right? I know you guys worked on imaginary stuff in Algebra 2, all right, but in pre-calculus, we're going to kind of gloss over that stuff. Different pre-calc teachers do different, emphasis. I think like Mr. Mills, he likes to go through like the imaginary unit and stuff like that, which is cool and good and useful. But in my mind, I'm more thinking about the future and calculus. And in calculus, you really don't use very much imaginary number stuff. So we're going to kind of just ignore it. We're going to gloss over it, okay? If you come across imaginary solutions, throw them out, okay? We only wanted to keep it real. So now let's get into the factoring here, where a is equal to 1. And we'll just do one example of these. Okay, so again, we have our quadratic equations, the more typical kind, right? When I say quadratic equation, this is the kind of problem you think about, right? So we'll just jump into one of them here. X squared minus 5x minus 33 equals 3. Okay. So very first thing, right, we should have alarms going off in our heads, because right now, the very first step we should do here is what? Subtract 3 from both sides so that it's equal to 0. If we're not equal to 0, we're not going to be able to solve this problem. Oops, I just rewrote the problem all over again. That's not very helpful. There we go. Okay, that zero product property is like, you know, the property, the strategy we're going to be using, you know, to solve a lot of these. So we really want to make sure we're equal to 0. Okay. So now, when it comes to factoring a quadratic, right? Hopefully, we should recognize that we know it's going to factor to be 2 binomials. Okay? And the way we will be multiplying those binomials, we know that we're going to need an x and an x here, because those two x's have to multiply together with that x squared. Likewise, we're going to need 2 numbers here. They're going to multiply to make that negative 36. But then simultaneously to multiplying to make that negative 36, they're also going to have to add, because it's going to be that number x times this number x. They're going to have to combine together to make negative 5x. So in other words, right, we need 2 numbers that multiply to make negative 36, but add to make negative 5. So it's like a little brain puzzle-y, teaser-y thing. So, what would that be? Yep, negative 9 and 4. And it doesn't matter whether you say negative 9 and positive 4 there, if you say positive 4 and negative 9 there, whatever. And yes, that's it. Okay? So this will require a little bit of mental gymnastics, right? There's no, like, you know, do this and it will always work out. You will have to kind of, you know, just play around with the numbers in your head a little bit. Multiply to make the last number, add to make the middle number, when your coefficient's 1 there. And now that we have 2 things that multiply to make 0, set each factor equal to 0 and solve. So there it is. X is 9 and x is negative 4. Okay. Questions on that? All right. What about factoring when a is not equal to 1? When that lead coefficient is some other number? Okay. So for example, 2x squared minus x minus 6 equals 0. Okay, so different teachers teach different methods. I will try to be accommodating to all methods, but of course I can't do the same problem like 3 or 4 different ways, so, you know, forgive me if you feel like your method is being neglected. I will be happy to, you know, teach through a couple methods right now, and then you guys kind of pick whichever one you feel most confident with, all right? The first one I'm going to show you, with this particular problem, I'm going to show you the guess and check, right, where you basically do the same thing we just did above. We know this thing has to factor to a binomial, okay? We also know that we're going to need an x here and an x here because we've got to make x squared. But in addition to making x squared, we have to have a 2 coefficient. Right? You know, something x here times something x here has to make 2x squared. Well, thankfully there's only one way to multiply to make that 2x squared, so I know one's got to be a 2 and one's got to be 1x, or just an x. Okay. And now it's the same idea as before. We want to come up with 2 numbers that are going to multiply to make negative 6, but then when we, you know, multiply 2x and this and add that to this and the x times the x, they should have to make a negative 1. Okay. So you can do this just by getting checking. For example, you can say, I don't know, let's say this is like negative 6 and positive 1. And then you check and see, does that work? Well, let's see here. Negative 6x plus 2x is going to give me a negative 4x, not a negative x. So, wrong, Mr. Widmeyer. Let's try again. All right. And then you can guess again, right? Let's see here. Plus 3 and minus 2. Question?
For 2x squared,
Uh-huh.
When you're trying to factor that,
Yep.
you said what multiplies together to get 2x squared?
Right.
Is there anything else?
So, right, you could do like 1/2 and 4, or like, you know, all those other like fractions and stuff like that. But generally we stick to integer coefficients for that.
So for other numbers other than 2, is it okay to do separate?
So for like, give me another example of another number you would be talking about. So I'll give you an example, like 6, for example. 6, you could do 2 and 3, or 6 and 1, right? And so, yeah, you would need to potentially look at both of those combinations to use whatever you need to be able to factor it. Okay, but again, we'll show you another strategy that's going to be helpful. Right now, it's obvious that it's just got to be 2 times 1. So anyway, so there's our two factors, and so we said each one of those factors equal to 0. And so you get 2x equals -3, x is -3 halves, or x is 2. All right. So there's that guessing and checking method. All right, next one. Let's look at this. So, all right, I'll do this one. So why not use 6x squared? 6x squared minus 13x plus 6 equals 0. So here, the guessing and checking method is kind of a pain in the butt, because like I was trying to describe to Jake there, that 6x squared, we could break that up into 2x and 3x, or we could break it up into 6x and 1x, and so we have two different combinations, which we then also have to match to the different combinations that we can multiply like 6, and so it's complicated. Okay, so who in here uses the x? Okay, a few of us. All right, so then I'm guessing then the other people use like something like this, where you take that lead coefficient, multiply it back to the 6, and so we get you try and figure out two numbers that multiply and make 36, but add to make -13, and then you break up the middle term. How many of you guys break up the middle term and then factor by grouping? Okay, and then everyone else maybe, I'm not sure what others. Am I missing another strategy that you guys use, or am I just? Is there something else that I'm missing you guys use? You don't remember? No? Okay. Well, we'll go through those. All right, so first one, the x. For those of you that have seen the x before, the x. 6 times 6, you get the 36 up here, and then you put the -13 down here. Those of you that break up the middle term, you'll see the same kind of ideas here, or similar kind of ideas. Okay, so is this familiar to anybody? Yes, okay, all right. So you have the 36 and the -13, and you try and figure out two numbers that multiply and make 36, but add to make -13. So what would those two numbers be? So it should be -4 and -9, right? And again, for those of you that split up the middle term there, you'd be finding those same exact numbers, the -4 and -9. At this point, you'd split up that middle term and then factor by grouping. And we're going to do another step here that's kind of magic. So once you find these two numbers, what do we still have to do? For those of you that remember using this x here, what do we still have to do here? Divide by that lead coefficient that we multiplied over in the original place. Yes. And then you simplify, right? So -9, 6 simplifies to -3 halves. -4, 6 simplifies to -2/3. And so then, since these are still fractions, the 3 will go back out as a coefficient and then -2. And then the 2 denominator will go back out as a coefficient and then -3. And that equals 0. Okay, so that's the magic x. All right. Multiply the a and c, so that's a times c there, and then put the b term in the bottom, and you figure out two numbers, the -9 and -4, that multiply the 36 but add to -13, divide by a, so again that's a, okay, and then you simplify, and then you rewrite it.
Wait, so does the denominator go out in the front, or the...
Denominator goes out in the front, that's right. Denominator goes out in front of the x. And that's, again, if you want to use this method, all right? There's a lot of, like, steps to me that don't make a whole lot of sense. They just, like, it works, and it's magic, and you get it to factor, okay? So I like this method less than the one I'm going to show you next, but if it works for you, that's great, okay? You now have it factored. You set it equal to 0, and you get 2/3 and 3 halves, which coincidentally are also the opposite of those simplified fractions that we had there. Not coincidentally, that'll be true all the time. Sorry, not coincidentally. They will be always that way, opposite of each other. Okay. All right, so that's that for the magic x, folks. There you go. I'm going to show you one more, though, for those of you folks that like to split up that middle term, just to refresh your memory some. And then for those of you that are like, I don't remember how to factor at all, well, you'll have to pick between one of these strategies here and go with it. And I'll be happy to help you get more practice with that as we go. All right, for those of you that like to do the middle term thing, you still multiply 3 back to the 15 and make 45. And so you want to come up with two numbers that multiply to 45 but add to negative 14. Okay? So it starts the same way the magic X does. We don't have that pretty little X there to help organize our work, but same steps. So what are the two numbers here? Negative 5 and negative 9. So we're going to then take our quadratic here and we're going to break it up. Minus 5x minus 9x plus 15 equals 0. Okay. So we're writing the equivalent quadratic here, right? All I do is take a middle term, the negative 14x, and break it up into negative 5x and negative 9x. Those two numbers that we found that multiply to make the 45 and add to make the negative 14. Now, at this point, what do we do? The 45 is the 3 times the 15 there. Is the 45 there, yeah. That's okay. Please feel free to ask. I know that some people remember this better than others, so. Remember what we do at this point? No, we factor by grouping. Group together the first two terms, group together the last two terms. Okay? What can we factor from those first two terms? An x. What can we factor from the second two terms? A 3. And I'm going to factor out a negative 3. Okay? Factoring a negative 3 out of negative 9 leaves me behind with a positive 3x. Taking a negative 3 out of positive 15 leaves me behind with a negative 5. And you can see, hopefully now, why I chose to factor that negative 3 out, so that we end up with the correct signs here. Okay, I'm going to positive x and minus 5. You'll know you're on the right track if you end up with the same factor here, right? Notice we have a 3x minus 5, 3x minus 5. Okay? This is like two terms now, right? We have this term minus and then this term right here. They both have a 3x minus 5, so that can be factored out. Taking out that 3x minus 5 leaves behind an x minus 3. And there it is, factored. And so we get 3x minus 5 equals 0, x minus 3 equals 0, and so x is 5/3, and x is 30 for the solution there. Okay. It's a question.
Do you want to do one of those two ways, like on a quiz or a test?
No. You can use the guess and check method. Do you have a third one that we haven't talked about? Or fourth one, I guess we haven't talked about?
I mean, I just want to guess and check. Like,
Okay.
I have to
That's fine. Absolutely. Yes. Use guess and check if you prefer. That's the way I do it, really. Like, I will rarely use this unless the numbers get, like, way out of control, and then I'll use it. But, yeah, absolutely. Feel free to use guess and check. That's quite all right. Yes, Kevin.
Where's the x minus 3 come from?
Great question. So, you're okay up to this point right here?
Yeah.
You'll notice that these two terms, they both have a 3x minus 5. So what I'm doing is I'm factoring one more time. If I take a 3x minus 5 out of this, I'm left with an x. If I take a 3x minus 5 out of this, I have the minus 3 there. So that's what's left behind. Do you see what I'm saying there? That's like undistributing that 3x minus 5. Okay. Other questions? I know, guys. Sorry, I'm going really fast, and this is not necessarily the easiest topic, but we will have more time. I can always come in for set and stuff, getting more practice too. All right. The last strategy, and this really is the last because it's like your last resort. You really don't want to come to this if you don't need to, right? Because it's just a mess. All right. First thing about quadratic formula: only use it when it's equal to 0. Okay, please don't try and use quadratic formula if your quadratic is not equal to 0. Okay? If you need help, you will need to know this formula too. I will not give it to you. You need to know it, okay? And I can almost guarantee it'll be on a non-calculator section too, so right, your calculator will be of no use. You need to know it and know how to simplify it and stuff too. All right? So, there are like a billion songs on YouTube. There are probably like raps you can listen to on YouTube. You know, whatever it takes. You know, you can do that. I will give you one thing that I've been shown before that I don't know if it's helpful or not, but at least it's catchy. You can do like "Pop Goes the Weasel," x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There it is. Okay? So, now you can remember the song forever, right? However you need to memorize it, though, memorize it. All right? So, let's use it on a problem. And in fact, you guys go ahead and try that. Okay? So there's your quadratic. Please solve it. Yes, it factors, but I want you to try it with the quadratic. Okay? So it does factor, but please use the formula. Okay? Please use the formula here to solve, just for the practice. And you're like, one more minute here, one more minute. One more minute. Okay, should look something like that. Okay. Again, quadratic formula, cumbersome, lots of like little substitutions and little arithmetic, kind of evaluations you have to do, lots of opportunities for mistakes. Alright. The plus or minus sign always used to mess with me when I was in high school, I remember, just because it was like, how do you do plus or minus to something, right? Because it's plus and minus. So I always like to think of breaking it up, right? 1 plus or minus 7 over 4 is then 1 plus 7 over 4, or 1 minus 7 over 4, and then simplifying those individually. So you get the 2 and the negative 3 halves there for your solutions. Okay? But yes, that means when you do get two nice numbers like that, that means this thing factored in the first place. But again, the quadratic formula does work every time. So if you don't want to have to learn how to factor, we will need to know how to factor, so you don't want to just skip over it. But should you get to an emergency situation, you're like, I can't think of the numbers, then just use the quadratic formula. Okay. Questions on any of that? Okay, so thus concludes what we were supposed to learn yesterday. All right, so we're going to start into what I wanted to get through today. We will not get done, but I'm going to get as far as I can. I apologize, but